Hello, and welcome to today's practical, where we're going to dive into the fascinating world of light. You've probably heard that light behaves in some pretty interesting ways, and today we'll explore two of its most important behaviours: reflection and refraction. When light bounces off a surface, that's called reflection. The angle at which the light hits the surface is called the angle of incidence, and the angle at which it bounces off is called the angle of reflection. What's really interesting is that these two angles are always equal. But what about when light travels from one material to another, like from air into water or glass? That's refraction, and in this experiment, we'll investigate how light bends when it passes through different substances. We'll be working with two different types of blocks today, an acrylic polymer block and a glass block. Through this experiment, you'll not only see reflection and refraction in action, but you'll also measure and compare the angles to see these laws at work. Before we dive into the hands-on part, let's take a quick moment to understand why this experiment is important. Understanding how light behaves when it reflects and refracts is essential for many real-world applications. For instance, designing eyeglasses, cameras, or even microscopes all relies on our understanding of how light interacts with different surfaces and materials. Knowing how light behaves can also help engineers create optical fibers for communication, or even design more efficient solar panels. So, not only will this experiment help you understand key principles of light, but it also gives you the tools to understand the real-world technologies that rely on them. Pretty cool, right? For this experiment, you'll need a ray box, slit, and lens to create a narrow beam of light. You'll also need a protractor to measure angles and a ruler to draw the normal line. As we mentioned in our introduction, we also need a rectangular acrylic polymer block and rectangular glass block. Finally, you'll also need some paper and pencil to write with. Now that we have our materials together, let's get into the procedure for our practical. The first step is to prepare the paper. Start by taking a large piece of paper and placing a 30 centimeters ruler on it. Draw a straight line along the ruler's edge. This will serve as the reference line for your setup. The second step is to draw the normal line. To do this, grab your protractor. At one end of the straight line you just drew, use the protractor to draw a second line at a right angle to the original line. Label this line with an N for normal. This will be the reference line from which you'll measure the angles. Step 3 is to set up the block. Take the acrylic polymer block and place the longest side against the straight line. Position the normal line so it runs through the middle of the block. Trace the shape of the block onto the paper without moving it. This will help you place the block in the same spot every time. Step 4 is to shine the light. Now, take the ray box and set it up so that a narrow ray of light shines at the point where the normal line intersects the block. This ray is called the incident ray. You should see the light entering the block. Step 5 is to mark the path. Move the ray box or paper to change the angle of incidence, which is the angle between the normal and the incident ray. The aim is to get a clear reflected ray, which is the light bouncing off the block, and a refracted ray, which is the light bending as it leaves the block. We can see in the diagram that we have got the incident ray, the reflected ray, and the refracted ray. Now, using a pencil, mark a cross at the point where the incident ray hits the block. Then, place another cross at the point where the reflected ray bounces off the block. Finally, mark the refracted ray leaving the opposite face of the block with two crosses, one close to the block and one further away from it. Step 6 is to measure the angles. After removing the block, use a protractor to measure the angle of incidence, angle of reflection, and angle of refraction for the acrylic block. Make sure to write down these measurements in a table. We can see here that the angle of incidence is 45 degrees. The angle of reflection is also 45 degrees. And the angle of refraction is 28 degrees. So we can add this information into a table. Make sure to fill in the rest of the table with a few other tests when you change the angle of incidence. Now that you've completed the first part with the acrylic polymer block, repeat the steps above using the glass block. Measure and record the angles of incidence, reflection, and refraction again. Now that we've completed the experiment, let's organize our data. Here's how you can record your results in a table. Split the table up into two parts, one for the acrylic block and one for the glass block. Then record the angle of incidence, angle of reflection, and angle of refraction for each of your 3 tests with each block. This will provide us with enough data to analyse the results. Let's take a moment to analyse what's happening in our experiment. First, let's consider reflection. According to the law of reflection, the angle of incidence should always be equal to the angle of reflection. In our data, the angle of incidence equals the angle of reflection in all tests for all of the blocks. Did you get similar results? Take a look at your measurements for both blocks. Do the angles match up as expected? If they do, it's a great confirmation that the law of reflection is at work. If not, take a moment to assess why our results are anomalous. It is likely due to human error, such as drawing angles incorrectly. Now let's talk about refraction. The light bends when it passes from one material to another. The angle of incidence and the angle of refraction should generally follow a pattern depending on the materials. For example, light bends more when passing through glass than when passing through air. How did your results compare for the acrylic polymer block and the glass block? Did the light bend more in one than the other? That difference can be explained by the refractive index of the material. And that's a wrap on today's practical. We've investigated the reflection and refraction of light, observing how light interacts with different materials. We found that the angle of incidence equals the angle of reflection, as expected. And we also measured the amount of bending as light passed through the acrylic and glass blocks. This practical has helped us understand key properties of light and how they're used in various technologies, from eyeglasses to optical fibers. Understanding how light behaves when it interacts with materials will not only help you in your studies, but also in understanding the world around you. Thanks for joining today's lesson, and see you next time.